Welcome to The Bootloader. I'm Paul Cutler.
And I'm Todd Kurt. The show works like this. Paul and I have brought 3 things to share, and we'll discuss them for about 5 minutes each. For detailed show notes and transcripts, visit thebootloader.net. Paul, what's your first one for this week?
So for the first time ever, I hit the explicit language button when uploading this podcast episode. And that's all because I would like to say is, tariffs are bullshit.
Yep.
Unless you've been living under a rock, you've heard about the massive tariffs the current American administration has imposed on goods from across the world, and it's killing the maker community. Want to order a handful of PCBs or make a small run to sell? That'll be an extra 145% due to tariffs.
Yeah.
Carrie Sundra of Alpenglow had an idea a few weeks ago, and that was for someone to create the website tariffsarebullshit.com, and she posted her idea on social media. By the time I saw the post and checked with my registrar, the domain had already been snapped up by friend of the show Jason Kuhn of Evil Genius Labs. The website is meant to share stories from the news of how tariffs are impacting small businesses. From the README, it asks if you've received any emails, watched any videos, or read social media posts from manufacturers and suppliers on how the tariffs are affecting them. So if you've seen a story in the news or on social media, or you have a story to tell yourself, start a discussion on the GitHub repo or even add a pull request. There are already more than a handful of stories, and I'm hoping more get added, as I think it's important to share the impact of these bullshit tariffs. And if you read just one article or watch one video, check out Carrie's YouTube video on how the tariffs are impacting her at Alpenglow. The video is just over 40 minutes long, but she takes 2 of the products she sells and breaks down where all the parts come from around the world to show how tariffs are going to affect her. My favorite part of the video is when she was talking about manufacturing the PCB for the skein twister. This one small 1-inch by 2-inch PCB has 27 different parts, and she compares how much it was to have it manufactured in the US versus China. It's pretty mind-blowing. We need more makers and small business owners sharing their stories too. And if you happen to see one, share it with tariffsarebullshit.com.
Yeah, that's so good. It's in some way, I'm glad that at least the concept of tariffs are being sort of talked about more, because of there's this exception for low price shipments called the de minimis exception, where you didn't get charged import fees from other countries if your shipments were small. And so that's how places like AliExpress and a lot of drop shippers from Kickstarter were able to like do their things. But usually you have to pay some tariffs, and usually it's, a couple of percent, 5-10% or something. And everyone kind of prices that into their business model. Like I've got a small business, and I've had to price that in. Like when the first Trump administration increased the tariffs from China to 25%, that was implemented irregularly on one big shipment, no tariffs. On another big shipment, 25%. And suddenly, there goes most of my margin for selling the product. And luckily, I had priced it so that I still had some margin available to me. So I made some money off of those, But it's just like, I've heard again and again that like tariffs are charged to the company of the products that we're importing from. It's like, no. It's on the people in the country that the tariffs are from. So like, I am paying the tariffs.
Right.
If I buy something from China. And like some of these, like most of these things we cannot buy in America. Like you could say maybe that, PCBs, there are PCB companies that will make PCBs in America. Yes, that's true. But all the parts that go on the PCBs, all of those come everywhere else, because there's hardly nothing made in America for those components. And so you have to go outside of U.S. anyway for the parts. And
Carrie talks about that a little bit in her video, and even just the price difference between what the PCB fabs here in the U.S. charge versus China. And she shares that a lot of the PCB fabs here in the U.S. are part of the defense industry. They can charge much higher prices than the average consumer is willing to pay. And those were things that I didn't know that were kind of eye-opening in just watching one video.
Yeah, that's how I first got into like knowing how to make PCBs, was with U.S.-based aerospace-focused PCB suppliers, and so the step up from just making a PCB is a PCBA, a PCB assembly where they put parts on, and there are these companies in the U.S. that back in the 90s you had to fax them a document, and they would get back to you with a quote. And pretty much the API to them is still the same. You send them an email, and they will come back to you. Whereas these other companies, and mostly China, you go to a website and you upload your CAD output files. You get an immediate quote. You can pay for it right then, and and then like a week later or 2 weeks later, or whatever, you get the products that you've designed and specified. Because they can do all this because it's all robots.
Right.
Like there's very little human intervention, and if you know how to design your products to use the robots more, it's like a lot faster too. And there's nothing like that in the U.S. yet. Like every time I do a big production run, I look to see, hey, how's the U.S. PCBA facilities? And they're all way too expensive because they've never had to focus on that. And who knows if this will ever like there's the one upside is that maybe this will cause the U.S. PCBA industry to happen more, but I don't know.
It's going to take them years, even if it were to happen.
Yeah, exactly that.
All right, what's your first one for us?
Well, sort of related in a way. It's about desoldering tricks. So if you've ever soldered together electronic circuit boards yourself, you've probably wanted to unsolder some of those components. And normally unsoldering parts from PCBs is a pain. And for some parts, it's almost impossible. You just will start again from a fresh board because it's I'm just going to mess the board up if I try to unsolder this. And that's not the most cost-effective solution, especially nowadays when parts supplies are a little bit unknown because of this ever-shifting tariff landscape. And so it might become more cost-effective for all of us hackers to desolder parts from existing boards and to repurpose them. And back in the COVID chip shortage, I knew small manufacturers who did this because they were able to get these little demo boards, these little dev boards for pretty cheap, and it was cheaper for them to buy these dev boards, unsolder the main chip they needed from it, and then solder it down onto their own project that they were then having a Kickstarter for. So I'm always on the lookout for techniques that are quicker and cheaper than what I normally do for desoldering. And I recently came across 2 videos to do that. The first is from YouTube channel Tinkering Daily that shows this really clever low-cost technique for removing surface mount components. To start, you get a soda can. No, really. And using tin snips, cut a piece of the can out a few inches long, about as wide as your finger, taper down one end of that strip that you've cut so that it's about less than a centimeter across, and then using sandpaper, reduce the thickness of the aluminum till it's about 0.08 millimeters thick. So you'll have to have some calipers. But now it's a thin desoldering shim. That thickness means it can slip underneath soldered down parts. So the process to unsolder the part is you stick the little shim in there, unsolder one side, slide the little shim a little bit farther underneath the thing you just heated up, and then unsolder the other side and move the shim over to get underneath the part you just heated up again, and the part's now unsoldered. And since it's made of aluminum, solder doesn't stick to aluminum. It'll just kind of peel off when it cools. So this is really clever. The person, Tinker Daily, shows removing multiple different kinds of parts like SD card sockets, audio jacks, large flash storage chips. It seems like a really, really kind of cool, almost like street vendor technique. Like you can almost imagine someone is going to upgrade the memory of your phone using a technique like this or something.
Sure.
So last week I got a soda can. I tried this out myself and it works. I'm not very good at it yet, but I'm going to totally add it to my toolkit of techniques whenever I need to unsolder stuff. And then later in the video, Tinker Daily also shows how to make unsoldering through-hole components with one of those little solder suckers, those spring-loaded solder suckers. And those solder suckers I've always had problems with. But if you really need to desolder a lot of through-hole parts and you have $200, check out the recent video from Jeff Geerling about the Hacko FR301. It's billed as a portable desoldering tool, but it's really just a motorized solder sucker with some better engineering. It solves the 2 main problems I've had with solder suckers. The solder sucker is a separate thing from your soldering iron, so there's always a little bit of a gap in both time and space. You have to heat up the joint and then move the solder sucker in and suck and push the plunger. Hopefully you'll do that fast enough. Usually it doesn't, so you always leave some behind, and the solder will cool down. And the other is that the solder sucker will clog. After a couple of uses, it clogs up. You have to kind of stop what you're doing, take the solder sucker apart, clean it out. The FR301 solves both these problems. It has a tip that's both the heater and the sucker, and when it sucks up the solder, it stores it in this little chamber that's separate from the nozzle, so it never gets clogged in normal use. It looks really well designed. It looks kind of like a soldering gun, but it's got this little whirring air pump that activates when you pull the trigger. And so if you're going to do a lot of through-hole rework, you just need to unsolder a bunch of parts. It's literally as fast as going dunk, 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 dunk to unsolder about five joints. It's like, if I don't need to do it very often, but if I do need to, I'm going to get one of these.
Yeah, I was just thinking for $200, that's a lot. But if it's really that easy, there's chunk, 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 and it's coming off just like that, I can see the making an investment like that.
Totally. So, Paul, what's your next one?
Philips, the company that makes everything from light bulbs to electric razors, has announced a new program they call Fixables. If you followed the right to repair movement, it's, and I'm quoting, a legal right for owners or devices to freely modify or repair products they own and stop making everything disposable. For example, without the right to repair initiative, we might not have been able to unlock our mobile phones and take them to another carrier like the law passed in 2014 in the US. Yeah. There are right to repair bills in all 50 states, and a handful of states have already passed legislation, including California, Massachusetts, and my home state of Minnesota. So it's pretty cool to see a large corporation jumping in. Now, Philips is starting very small, with the first part being one 3mm comb for the Norelco One Blade, a men's electric shaver. According to an article at Tom's Hardware, the program is primarily for the Czech Republic at launch, and Prusa Research and LePub have partnered with Philips to help with the local maker community adoption. Philips has also added a web page where you can submit a request for them to add a specific part. Too many electronic devices are disposable these days, and I love seeing a company dive into something new like this.
Yeah, this is so cool. It's like if you've ever been on Thingiverse, Printables, any of these other 3D printer sort of model websites, or if you've been on the 3D printing subreddit, the functional print subreddit, there's all these little add-ons that sometimes, oftentimes they're for home grooming things. They're like things to make your toothbrush easier to hold, or like I've seen add-ons for different kinds of blade things like this. Like this is for I think it's a motorized razor, and it turns it into a beard trimmer is what the Fixables thing. And this is sort of the perfect application for a 3D printer because you can customize it pretty easy for different lengths if you want. And it doesn't need that much physical strength because it's just this little plastic thing that goes between the razor and your face. There's not a lot of physical stress on the part. So it can be a thin kind of delicate looking thing. And the fact that Philips is supporting this means that we get good, accurate measurements. We don't have to reverse engineer it.
Exactly. And you mentioned Thingiverse and Printables. They have their own Printables page, so you can actually subscribe and follow them too to see them add more parts over time.
Oh, that's cool. That's awesome. Yeah.
So what's your next one for us?
All right. So are you up for a 2.5 hour documentary about a 1980s video game?
I always am up for a video game documentary.
All right, so on YouTube, there's this video called "Resurrecting Sinistar." It's a documentary by nom de plume musician Cinemax about the revolutionary and scary as heck to me as a kid coin-op game Sinistar. Sinistar was created by Williams Electronics, makers of other famous video games like Defender, Robotron, and Joust. I played all these when I was a kid. I loved them. It was the first game to feature real sampled voice audio like "I am Sinistar. Beware, I live." And and it would play this while you're playing the game when the big Sinistar monster's coming after you. It was terrifying. It also had a 49-way joystick and blistering fast gameplay. It was like one of the hardest games I've ever played. If you've never seen it, gameplay is vaguely Asteroids-like, but you shoot the rocks to mine bombs that you use against this growing sentient planet called Sinistar. The documentary is quite long at over 2 hours, but it goes into the history of the team that created these games, the challenges of making video games at all in the 1980s, some of the assembly language tricks needed for certain game features, and some of the technical hurdles that made Sinistar unique. How did they do audio? How did they make that 49-way joystick work? It also discusses the challenges of reconstructing a modern working build of the game from 40-year-old source code. This is because a couple of years ago, the source code for several Williams video games appeared anonymously online. We have a link to the GitHub repo for all this if you want to look at what 1980s source code looked like. Along the way, the documentary has exclusive interviews with members of the Williams game team, project lead software engineer Noah Falstein, sound engineer Mike Metz, and game designer John Newcomer. You can track Cinemax's work, who made the documentary, on his public GitHub repo, so you can see how he's been modifying the code to work with sort of modern tools. Oh, also, the video has chapters, so even though it's 2 hours long, you can like think of it as like maybe an eight episode miniseries.
Yeah, you
And
should.
just
And
watch it.
it's closer to 3 hours than 2 hours at that, too. But
Yeah,
I started
totally.
watching it, and next thing I knew is I was 2 or 3 chapters into it. A half hour had gone by just like that. And it's engaging. And it's very nostalgic and takes me back to when I was very young and playing in arcades.
Yeah, no, it like Sinistar would always call to me. I mean, like literally, because its attract mode is it would occasionally play these scary vocal sounds as you're just walking by. All right, Paul. So what's your next one?
I recently came across Kiwix thanks to Alex Glow on the social networks. Kiwix is a nonprofit dedicated to providing offline access to free content. It's free and open source and allows you to make compressed copies of entire websites like Wikipedia or Project Gutenberg. Their homepage mentions 50% of the world doesn't have access to reliable internet, and this is one way to bring the world's content to those areas without good internet. Kiwix supports the whole stack. They have a Kiwix server you can run on a Raspberry Pi or any other major OS like Windows, Mac, or Linux. But if you use a Raspberry Pi, you can also use it as a wireless hotspot to serve these local websites to anyone connecting. Almost any model of Raspberry Pi will work from the Model 3B on up except for the 02W. Or you will soon be able to buy a Pi hotspot right from Kiwix that comes with an SSD, Pi 5, real-time clock, and more. So what does Kiwix do? It allows you to download entire websites and serve them offline. You can have Wikipedia, which I think is only about 57 gigs for the English version, and host it locally. You can visit library.kiwix.org to see the websites they make available for offline use, and it includes 1,000 books, as they call it. They have tons of documentation available, from Linux distro docs to Python documentation to all of the free code camp to teach you how to code. They use the Zim file format, which is an open document format with excellent compression. And they clearly know their target audience. I was amused when I was on the Kiwix hotspot page, and they have multiple personas that come with the Kiwix preloaded. One who wants all of Wikipedia, someone that might want medical information, someone who might want TED Talks, computer docs, and my favorite, doomsday preppers. Because when World War III starts, someone has to save mankind's knowledge.
This is amazing. As someone who's tried to mirror a website by hand with like clever invocations of wget and getting a somewhat functional site, but not really, this is a really cool setup. Because so many of our documentation setups now aren't just a single linear page, but rather these like complicated websites. So we need something like this. This is really neat.
Yeah, I agree. And what's your last one for us?
All right, so. It's about a hardware thing for musical synthesizer stuffs. It's called Euroknob. It's a knob. It's a jack. It's a knob. No, it's Euroknob. So what is this? The talented hacker Mitzela, perhaps most famous for his self-proclaimed smallest and worst MIDI synths that fit inside of a USB-A jack or a USB-C jack, recently posted this really clever hack that allows you to plug a knob into a headphone jack and turn it to adjust values. How does this work? So imagine you got this Eurorack modular synth set up with wires going all over. Some of the wires carry these control voltages, maybe from a slow oscillator module, a low frequency oscillator or LFO, that alters the behavior of another module like a filter. Thus, this wire is what's making the sound rhythmically go wow, 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 wow. But now you can just unplug that wire, plug in a knob, and turn the knob to change the filter directly and make it wow, however you want. So what is this magic? The Euroknob solves a common problem in modular synths like Eurorack systems. Some of these synth modules have inputs, with jack inputs, but no corresponding knob on their front panel to change the value. So you have to just wire stuff up even to just see what this input does. And the way he does this is his hack has behind the jack a special type of magnetic position encoder. So it's got a like in on axis, it's got the jack and the encoder below it. So when you plug a cable in, the jack just acts like any old jack. But if you plug in his special knob, the shaft of which looks like a plug, but it has a small embedded magnet in it. So as you plug the knob into the jack and turn the knob, the magnet rotates, which the magnetic position encoder can read. And these magnetic encoders are incredibly precise. The cheap ones he's using is the AS5600. It provides 12-bit position accuracy, and they're effectively noiseless, unlike the DACs of most of microcontrollers. I don't know if you've ever hooked up a pot to an Arduino or something. Even when you're not touching it, the value will like oscillate around like 5 or 6 values because there's just like inherent noise in the system. And this doesn't have that because it's just measuring the magnetic field, and that doesn't really change. There's no magnetic noise in our lives usually to cause it to do that. And I've been wanting to use some of these AS5600 magnetic position encoders for a while because they seem like a really good knob solution. They're little I2C devices. You can just talk to it. One thing that's been stopping me is trying to figure out how do you mount the magnet, because you need a magnet, and it needs to be on the shaft of the knob. And so I'm thinking of using his idea, not even using the jack aspect of the jack, but just using the jack and the plug as a mechanical system to hold the magnet. So if you want to look up this project, Mitsala has published a blog post on how it all works, and then a GitHub repo with his PCB design, software, and CAD files.
Yeah, the write-up is fantastic. He walks through how he built the whole project and shares the CAD files in it and everything. The only disappointment I had was towards the end. He's like, this is a prototype, and I don't plan on moving forward with it because it's probably not viable long term or something like that. And I'm like, oh, you went to all this work.
Yeah, all of his projects are like this. Everyone go to his webpage. He's been doing these things for like 10 years. They're like little art pieces almost, and they could be manufacturable and productizable, but no. He does it for the fun of it.
Well, why else would you do it?
Right.
Well, that's our show. For transcripts and detailed show notes, visit thebootloader.net and check out the show notes to also follow us on all the different social networks. Until next time, stay positive.